Hi, everyone. Welcome, or hopefully welcome back to another episode of the Reliability Matters podcast. For those of you who continue to count, this is episode number 138. Today, we're taking a deep dive into the world of precision and craftsmanship, two crucial elements in the realm of hand soldering and rework of circuit assemblies. Whether you're a seasoned electronics enthusiast, a hobbyist, or just someone with a curious mind, this episode promises to demystify the art and science behind hand soldering and rework. Today we'll be exploring the latest tools, techniques, and trends that define this intricate process, shedding light on the unsung heroes who meticulously bring circuit assemblies to life, or in the case of rework, back to life. There's archaeological evidence that soldering was employed as early as 5,000 years ago in Mesopotamia. Soldering and brazing are thought to have originated very early in the history of metalworking, before 4000 BC. Sumerian swords from 3000 BC were assembled using hard soldering techniques. While soldering applications have morphed and expanded over the centuries, the basic rules of soldering have not. On this episode, we're going to talk about an obvious soldering application, at least for my audience, and that's the soldering of electronic assemblies. From the evolution of hand soldering with numerous technological advances to the challenges faced by DIYers and professionals alike, we've got it all covered, thanks to my subject matter expert, Debbie Wade. Debbie is the Managing Director of ART, A-R-T, Advanced Rework Technology, a fully independent training organization which has been presenting various training courses for over 30 years. Debbie's been in the electronics industry for over 20 years, with the last 15 of those years at Advanced Rework Technology. Debbie comes to us very well credentialed. She's the chairperson for the IPC A620 Training Committee and IPC European Training Committee, with her Master IPC Trainer status for IPC A600, 610, 620, 7711/21, and J Standard 001. She's an expert in the field of fabrication, assembly, process, acceptance of boards, and cable assemblies. Debbie's been presented with numerous awards from IPC in recognition of her contribution to IPC standards and training courses. So, grab your soldering iron, metaphorically speaking, get ready to dive into the Flux and join us as we unravel the secrets of successful hand soldering and rework. Stick around for valuable insights, practical tips, and maybe even a few stories from the trenches of hand soldering and rework. My conversation with Debbie Wade begins in just a moment.
Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Hi, Debbie Wade. Thanks for being my guest today.
Hi, Mike. Thanks for inviting me.
Of course. I've always found the hand soldering portion of our industry to be exceptionally unique, and one of the pieces of evidence of how unique it is every year at IPC Apex Expo, they generally host a hand soldering competition, and
Correct.
I can't think of any other part of the assembly process that has a competition every year at a show. I don't see a stencil printing competition. I don't see a pick-and-place competition. I don't see an AOI competition. I do see a hand soldering competition, which just illustrates how much it combines a skill, an art, and a science, unlike probably any other part of our industry, or at least part of the assembly side of our industry. Agree?
Mm-hmm. Very true. You are correct. It is an art, and it's not just based around equipment being used. It's also based around the individual. It does take a very unique person to have those skills to create that solder connection time and time and time again.
Yeah.
To work with such small components, it's just amazing, the complexity and the nimble-fingered of those individuals.
Yeah, I think I would be, in fact, I know I am certainly not going to win that hand soldering contest.
Me
even
neither.
even though I know from a scientific standpoint or from a rule standpoint, I know how soldering is conducted. I understand the principle. I understand flux. I understand heat. I understand, what a good solder joint is. These little fat stubby fingers just can't seem to do it. I can't draw for the same reasons, right? There's something between here and here that is severed somewhere in between.
I think I'm the same.
So when I do see it done well, it's something I can kind of appreciate. It's like, this is probably illustrating how much or too much geekiness I have, but I can actually appreciate a really good quality solder joint, almost like I can appreciate a piece of art, right? Because it is an art. And speaking of art, ART, your company is a very clever acronym, by the way, because it is, at the end of the day, a piece of art, right? To be able to hand solder properly. And advanced rework technology happens to have the acronym ART. I just find that very, very fascinating. Was that done on purpose? Was it advanced rework technology? Oh, it happens to spell art, or was there forethought in that?
I could give you a bit of history, but I can't fully give you the entire answer because the company was founded 35 years ago now, and I'm not quite the original founder of the company, but I have been with the company now. Your intro did say 15 years, but it's actually now about 22 years.
Wow.
The founder, Barry Morris, started the company after lots of experience with the industry. He used to work for Marconi College, based in the UK. And one of the reasons for advanced rework technology was to expand on, it's not just soldering, but when things go wrong, how do we rework? Hence why I wanted the word rework within the company name. But also, before the days of Google and using the internet, you may have to pick up a telephone book. You may have to look at business cards. And he wanted to make sure the company name came first.
Yeah,
So
I remember.
Perhaps he went with a name that starts with an A.
Yeah, I remember back in the day when telephone books were more than just doorstops, as they are today.
Correct.
If you needed a plumber, I would switch over to the plumbing section, and then I would see AAAA plumbing, and then the next one would be AAA plumbing, AA plumbing, A plumbing. To your point, right? They all tried to kind of game the system. Yeah, very good. So your company, Advanced Rework Technology, ART, is an IPC electronics training provider. Tell me what types of training services you provide and to what types of customers you provide them.
Okay, well, you said for one, we are an IPC training partner. We can train from every aspect of the industry, from the design. We do have the CID, Certified Interconnect Design Trainer, working for ART, all the way through to the soldering, the rework, the inspection, the box build. We are able to offer the training to all three levels of IPC, which is the Certified Standard Expert, the CSE. We can do the CIS, which is the specialist training. We can do the CIT, which is the trainer level training. But we can also offer bespoke training. So when ART first became a training provider, before we became associated with IPC training, we would work with the customer to put together a bespoke syllabus based on the needs of their company or the needs of their product. And that's still something we can do to this day. They may not need IPC training for internal quality requirements or for contractual requirements, but they need to be trained to a recognized level. And when it comes to the companies with the industry, it really does vary. It could be a commercial company. It could be military, medical, aviation, aerospace. It could be automotive. It really does vary based on, at the time, the needs of the industry.
And what are the advantages for a company to send someone for training, or for a person to be sent for training, in getting an IPC certification, and how does it affect their daily work, and maybe even more importantly to the individual, how does it affect their career track? Do you have any anecdotal comments on that?
Yeah, well, for one, with the individual, it shows that they take pride in their work.
Right.
That they do have a knowledge, understanding of process, material selection. They understand tip selection, different solder alloys, different processes, but also they will understand how to implement that into their day-to-day job role and their day-to-day function within their company, which then has a knock-on effect. The company can then advertise to the outside world that they just work to a recognised standard. They have personnel certified, qualified to a particular standard. And with IPC, every 2 years they have to recertify. So they can then demonstrate again to the industry or to their company that they're keeping up with changes to the industry, changes to products, and changes to IPC revisions.
If I were to decide tomorrow I'm going to start a assembly business, I can pretty much know that I'm going to need certain types of equipment. I'm going to need a stencil printer. I'm going to need a pick and place machine. I'm going to need an AOI machine. I'm going to need conveyors, et cetera, et cetera. The list goes on. But of course, mistakes happen, or my board might be designed so that something can't be soldered automatically. It has to be hand soldered. What types of equipment or what types of tools do I need to consider in having the ability to hand solder components and rework components? That's often overlooked, I think. And particularly the rework side is often overlooked, and then people scramble, and they may know more about the equipment to produce a product than they do the equipment to repair a product. So what's your kind of short list inventory of recommended tools or equipment that one would need?
You are correct in what you said there. It's overlooked. You are right they will need a lot of the automotive equipment if they're doing obviously a large batch, or if they have a rather large turnover of assemblies or products. Yes, they will the automotive equipment, and they neglect to consider the hand soldering or hand rework equipment. Or they may say, we've got a soldering iron in place, we have 2 or 3 tips, that should be enough. And I often say to customers, the simple thing of you need to spend money to make money. You need to invest in the simple equipment. When it comes to the soldering iron, it's really important that you have an array of tips. Not just one tip does all. Yes, the process of tinning the tip, maintaining the tip, creating the heat bridge, getting the heat transfer remains the same. But as component style changes or component size changes, you will need to change the tip. So I always say to them, you need to invest in the good quality tips for what you need. If you're trying to remove, say, an SOIC, you could do what we call the bodge job of using 2 irons like a thermal tweezer to tweeze and lift. But you're going to need 2 irons, 2 tips, where we could get the bifurcated block that fits in the soldering iron handpiece designed for that component. Because you don't want to damage the component,
right?
Damage the board, where it could be just the components out of alignment. And all you want to do is reflow, realign, and reuse that part. Where the board could be worth tens of thousands of dollars, the part may only be worth $2, but do you want to risk damaging the board because you're not investing in the equipment you need?
I remember seeing someone not that long ago, actually, reworking a component, and they were using a heat gun, but it wasn't a hot air rework machine. This was literally this red heat gun designed more for shrink wrap or shrink tubing or some other application. And it was effective at causing the solder to reflow and lifting the component off. I was just wondering, if I had a heat sensitive camera, I would assume I would see this big red circle well beyond the footprint of the part. And I was just wondering how many other parts got inadvertently reflowed at that point. So I guess there is a strategy, a wise strategy to having the right tool for the right application, even though there are other ways to do it. I mean, I guess technically we could remove a component with a chisel and a hammer, right? That would be effective, although it may not render the board useful after that. Have you seen in your experience people using the wrong tools for any specific applications, thinking that they had their own little personal cheat?
Yes, I see that regularly, and you gave the perfect example with the hot air guns. I've seen people use more like paint strippers, the hot air guns, or as you said, for shrink sleeving, or if they've gone into their cable department and picked up the hot air gun they'll use to shrink the boots to connectors and to the back shells. And you say to them, yes, it may be a hot air gun, but is it repeatable, reliable, and safe? Safe for the board or the assembly, and safe for the individual. They may be used in such a manner they're going to harm the assembly or harm themselves. Yeah. So we have to say to them, can we control the heat correctly? Can you control the airflow correctly? Because you don't want to affect surrounding parts. Or you say to them, it's densely populated. How are you protecting surrounding parts?
Right.
And you can then suddenly see that light bulb comes on and like, oh, we didn't think of that.
Right.
And then we say, is it documented? Has this been approved as part of your process? And again, they're like, oh, we didn't think of that. And I said, if you were to have an audit or a customer visit, you do not have a traceable process. And if there is going to be any downtime, any failures, and they come back and look at your process, that's where they can see there's some issues.
Yeah, issues. Yeah, yeah. To say the least, definitely
that's
issues.
A polite way.
That's a polite way to say it, right? Exactly.
Yeah.
Let's start. I do like to start at the beginning, right, at the basic level. So we'll take kind of a beginner's mindset to this. So I apologize for starting so far back, but just to bring my entire audience up to speed, can you explain the basic principles of soldering? You started to, you started it with, you have to tin the tip, you have to whatever, but explain the basic principles of soldering and how they apply to circuit assembly rework and hand soldering in general. Let's just kind of walk through the basic X number of steps for a successful soldering application.
Okay, so of course we are trying to create a connection between the two parts we are trying to join, or the parts we're trying to join. So it is vital we look at equipment first. Do we have the correct equipment to do the job correctly? That's based around the design of the assembly, the board type, the board material. We need to consider the component type, the component material. We then need to ensure we have the correct tip to suit the connection. So basing the tip around the size of the land or the size of the pad. We don't want obviously a too large a tip that overhangs the pad and it's possibly going to cause thermal damage to the surrounding surfaces, the laminate, the substrate of the board. We don't want the tip too small. We're having to leave the tip on there longer. Again, end result's generally going to be thermal damage. We need to make sure that we've set the correct temperature for the alloy we're using and the materials we are using. And as I had already stated, we're then going to tin the tip. One, that will ensure we are at reflow temperature. We want to shy away from the very old school ways where I've seen people bring the tip towards their face. They like to do that because they can often feel the temperature of the tip, but also it lets off an aroma. There's a scent when the tip is hot. But how your nose and your skin reacts to the temperature is different to how solder is going to react. So easiest way to know a reflow temperature, tin the tip. We can then obviously clean the tip to remove any oxidations, any contaminations, and then we're going to create the heat bridge. So we're going to then apply the tip to the areas we are wishing to join. We will feed the solder on to ensure we have a reflow, and then bring the solder away from the tip, because we don't want to burn off the flux. We want the flux to disperse out away from that area to clean the area. If we were just feeding the solder onto the tip, the flux is burning off. So it's not going to do its job correctly. And the solder will flow towards the heat source, hopefully, if it all goes to plan, giving us that correct joint and hopefully the correct reliability for what we need.
And there you go. So if we can just do that and repeat it, you all have a certification. they're on their way to you now in the mail. First of all, going back to the beginning of our conversation when we talked about how much of an artwork this is, that was super emphasized when you said you can smell if the tip is ready. And, when it comes down to using more than just one sense to perform this act, then you can tell it's very much a skill. You almost sounded like someone describing how to evaluate a wine. The smell has to be right, and that just goes to show how experienced you are doing this. Because I don't think I would have noticed the smell. I would have noticed the smell if the board caught fire. I would have noticed that, but I don't think I would be able to tell if a soldering tip is ready simply by its smell. That is a really good indication of how experienced one is when they can just feel it's ready through a multitude of senses. What are the common challenges individuals face when hand soldering electronic components, and how can they be overcome? These challenges might be in their skill set, it might be in their tool set, it might be in the component design or location. What are the typical gotchas in this business?
Mainly design. We may have boards with large ground planes, power planes, just acting like a heat sink, especially if it's, say, a through-hole part where they need to obviously get the heat to penetrate through the barrel to encourage that solder to flow. If there is a heat sink, a ground plane within the board is going to draw that heat away. So they may have to look at other ways of heat enhancement. They may have to preheat the board. They may have to apply some back heat. Obviously, what we don't want to do is apply solder to both sides of the board, because as the solder penetrates into the barrel, we may get an airlock. There may be a void that is not visible to the naked eye. But within that void could be air, could be moisture, could be a cleanable flux that's now entrapped within that solder connection. We also have to overcome materials, for example, ceramic. We don't want to apply direct heat to a ceramic component. We're going to get a rapid thermal expansion that may obviously damage that part. So we do have to obviously look at the process on how we're going to apply the heat to different materials. And you're right, it is also down to their skill set. They may be more of a hobbyist solderer, where they just solder at home things like remote control cars. They may tinker with their hobby at home and have a hobbyist kind of iron, which is not going to match the irons they're using within the production area. So they may quite know how to solder. They may know the principles behind how to solder, but then putting it to practice isn't always as easy. So it can be a challenge. But with the correct training, the correct material, correct equipment, it can quite easily be overcome.
My father, I remember growing up, my father had a soldering iron that I used to tinker with, but it was not I've seen them in industry before. I'm not sure if they're really designed for this application, but it basically had a trigger switch on it. And you pulled the trigger and it was instantly hot, allegedly. And then you let go of the trigger and it cooled off very quickly. And I look at that as opposed to the ones that plug in, that you turn a dial, you set the heat, and it's on all the time until one turns it off. Are you aware of those old trigger soldering guns?
Yes.
And are they designed
exactly
for this are they designed for this application, or are they really designed for other things?
The answer to that question is simply no. Soldering guns are not designed for this industry. If you were to have an ESD meter available and you put that close to the soldering gun, every time you pulled that trigger, that needle will move. It's creating a charge. So as you complete that circuit, for that tip to get hot, is creating a charge. So if you're dealing with any parts known to be ESD sensitive, you are potentially going to be causing damage to those parts. Damage is not visible to the naked eye, but you may have an instant failure, or you've just degraded the part. So over time, especially out in the field, that part may fail, and you have some very unhappy customers. So they're more designed, as you said, for hobbyists. In fact, they're quite often used in the plumbing trade when brazing the copper pipes together, but not really designed for electronic circuitry.
Yeah. I produce a lot of content, technical content, and I have subscriptions to various photograph sites and things like that. And I remember searching for a hand soldering image, to make a point in a presentation. And there were two that stood out, one more than the other. One was a hand soldering gun, a soldering gun that one was using. And I remember thinking, I don't think that's the right, but I didn't realize what the implication was. I just kind of knew enough to go, that wasn't the right tool. So clearly that was just some artist, not a soldering artist, but a photographic artist trying to make a picture that they could sell. And the other one, which I found hilarious, and I looked for it, I can't find it anymore, but it showed, it was a typical, I think it was like a Weller soldering iron, blue handle, and then you had the stock, the metal stock leading to the tip. And quite literally, their hand was on the metal stock. And she looked like she knew what she was doing. She was wearing her little safety glasses and her white lab coat, and she's holding it here. It's like, okay.
I have seen that photo many times on social media.
Okay, yeah, it's made its rounds.
To do. And we always say to people, even when we do our basic introduction to soldering training classes, for the real new people, we always say, this is the end that gets hot. And I often make reference to that particular photo that often does the rounds, where she does look like she knows what she's doing, but she's holding a hot end.
Okay, so other than holding the wrong end, the hot end of the soldering iron, what are the other common mistakes you see kind of just on a regular basis, the things that keep you in business, essentially? What are common mistakes people make in either hand soldering or rework in general?
When it comes to hand soldering, the common mistakes are too much pressure. They think if they press harder, they're going to get a quicker heat transfer. But the problem with pressing harder, there's more chance of causing damage, measling, lifting a pad. Too high tip temperature. Again, if solder isn't flowing correctly, not wetting correctly, they instantly think, if I bring up the temperature, then solder will flow better. But they don't consider the principles behind. We set the temperature based on the alloy and based on the board materials. Incorrect use of flux. So again, if solder's not flowing properly, they think, if I just flood the area with flux, then solder will flow better. When it comes to rework, it's often the same problems, too much pressure, too much temperature. Or with rework in particular, lack of patience. They're trying to rush. They're trying to get that part off as quickly as possible. And we appreciate you do need to get off that heat and get off that part within a set time frame, so you don't cause further damage or thermal damage. But if you're trying to rush, you are going to make matters generally 10 times worse, not better.
I think lack of patience probably is a common mistake in way more many things than just hand soldering and rework. I think that can be applied, not even out of this industry. It can be applied to life. One of the things that I'm in the cleaning world, right? So, our job is to clean up all the stuff that your students do, from a Flux standpoint. And I've always been amazed at how often excessive flux is added in a hand soldering application, particularly no-clean flux, which could be quite problematic if they don't clean it, because they put so much flux on it doesn't all get activated, and of course then the no-clean is no longer a no-clean. It's now active, harmful residue. And I always remind people in the context of cleaning that in almost all cases, the solder wire, has flux within its core. And in a perfect world, and I realize we don't all live in that world, but in a perfect world, there should be enough flux in the core to adequately solder the solder joint. And there are occasions where if it's a high mass area, it's just not enough flux in that core, so you have to add flux. Is that Pollyannish on my part to think that most soldering applications do not need the application of additional flux, or am I off there? Is flux generally, is it recommended that flux generally be added in addition to what's in the core?
In all honesty, I'm in the same mindset as you are. I always tell people, try and rely on the flux within the solder wire whenever you can. Additional flux for initial soldering isn't normally required. Unless they do have an unusual plating type.
Right.
If they do, as you said, have a large mass board where they do need the additional flux to aid with the heat transfer. But it's normally a case of their technique's not correct. As I said, if they have carried on feeding the solder wiring onto the tip itself, the flux will instantly burn off on that tip. So we always say to people, if you then bring the solder around the opposite side, that will then allow the flux to do its job correctly. But again, you are right when you said about no clean. The title is very, very misleading. It's not
that's great.
Flux,
I'm so happy you said that. Yeah.
It's the leftover residue. As long as that residue has been, the flux has been burnt off, leaving behind that residue, it may not need to be cleaned.
Right.
But just because the term no clean flux doesn't mean it can stay there. As you said, if it hasn't been activated correctly, we still have the flux on that surface, and we will get that a lot with no clean. It will disperse out away from the heat source a lot quicker than a lot of the cleanable fluxes. Yeah. So if you apply too much, the incorrect quantity, the wrong location, and that area hasn't been heated correctly, then you are going to have problems with corrosion. You are going to have problems with reliability. But because of the term no clean, people think it's not important.
Well, people misinterpret the term no clean, and what they interpret it as is don't clean. And yes. No clean is simply the species of flux one would choose if their plan was to not remove the residue. You wouldn't use an organic acid, an OA flux, if you were not going to clean the board, clearly. You wouldn't even use an RMA if you're not going to clean the board. But you would choose a no clean if you're not going to clean the board. But really, I think no clean should be more appropriately defined as low residue. It is a low residue flux. And when the reflow process is conducted properly, then the flux is either burned off or encapsulated and rendering it inert on a board from an electrochemical migration standpoint. But that is a mistake that people make, is they apply flux to areas where there is not going to be heat applied. And if that's the case, as long as you're cleaning the board, then at least you can remove that residue, the unactivated, all the volatiles in the flux, all the bad actors in the flux. The other issue that I see mistakes being made, and I'm not sure if this is something that that one who teaches the art of soldering would teach, but I'll add it to your curriculum because it would help my customers a lot. And that is back in the, back when everything was wave soldered, and of course boards are still wave soldered, a typical application method, flux application method, it was a foam fluxer. And that put on just huge volumes of flux, just dripping from the bottom of the board. But the entire board went through a preheat and a soldering process, so it burned off those foaming agents. Flux has a number of components to it. It has a lot of things to do, and one of the things that are seldom appreciated is it has foaming agents to allow it to foam in a foam fluxer, and those foaming agents are burned off during the reflow process. I've seen people in wave soldering applications and even in hand soldering applications take a little spray bottle and apply a generous amount of flux, like their uncle's in the flux business or something, and they're spraying all this flux. But the flux is being applied to areas where the heat is not. And that renders all of the ingredients that make flux work, that are supposed to be burned off during the soldering process, it keeps them intact. And when one goes to clean the board, the foaming agents are there waiting for their cue, and all of a sudden there's agitation and a fluid, a liquid, applied to the board for the cleaning process. And the foaming agents go, we got a job to do. Let's start foaming. And next thing you know, there's this, almost looks like an old I Love Lucy episode, where foam is just flowing out of all the walls of the machine onto the floor. And now suddenly you have a floor cleaner rather than a board cleaner. And that is really due to excessive flux being applied to the board to areas where there is no heat being applied. Is that something that is specifically considered when teaching someone how to properly solder a joint, or is that just way off in the periphery somewhere?
That is something that hopefully would have been considered by the process engineers when they're setting up the process, looking at material and process compatibility and process selection. But one problem I've come across, going back to the no-clean process, or the use of no-clean flux, I always say to people, be very careful with the quantity and location. If you're adding additional flux during your process, a good example, a few years ago, we were called in to a customer because they had some reliability issues and wanted us to go and do some consultancy work for them. And they said, we are testing our boards and sometimes they're passing test, sometimes we're not even getting a test result, it's failing test. So we looked at their process and straight away I said, I think we know your problem. Are you using external flux? And they said, yes, but it's no clean. I said, the problem is you're getting such a build-up over a test point. On some of them, there's a smaller quantity of solder on that test point, and the test probe is making contact. On the next batch of boards, that build-up is a lot larger, and once that residue is cured and hardened, it's quite like rock. And that test probe can't break through, so they're not getting a result at all. It was something as simple as how they were applying the flux, where they were applying the flux, that had that knock-on effect.
Yeah.
So as soon as we said, why are you applying flux when you can rely on the flux in a solder wire? And they said, well, we just thought it'd make the process easier, make the process of soldering quicker, and it's no clean. And again, I'm like, the term no clean doesn't mean you can leave it there. There are instances where you'd have to remove it, and that was the prime example.
Yeah. It's funny how that phenomenon lands in your world as well, because I think we're the only victims of it, but clearly not. How has hand soldering specifically evolved over time? And realizing that time has affected many parts of the electronic assembly industry. Time has affected component density. Time has affected component size. Time has affected many other factors. Time has affected environmental legislation that has altered the way metallurgically metal flows. I'm thinking of the difference between 6337, tin lead and lead-free alloys. They reflow differently. How has, if someone was certified to whatever standards were out there 25 years ago, how current or obsolete would that knowledge be, assuming that person never learned anything else over the last 2 or 3 decades? Does that make sense?
Yes. The method of soldering remains the same. There was a lot of scaremongering saying, oh, now we're going to PB3 or lead-free. We've got higher melting points. The way we solder is going to change, which was not true. The process of soldering, the principles of soldering remains the same. It was things we had to consider was, yes, we do have a higher reflow temperature, which may mean in turn we need a slightly higher tip temperature. We may need to leave the tip on there for a fraction of a second longer. They had to then be aware of, once that joint solidifies, the surface appearance may differ. It may not look bright and shiny, and we were always led to believe a good joint was a bright, shiny joint.
Right.
And we know that's not always the case, but that's not just with PB3, that's any higher melting point solders. They won't always look bright and shiny. They will look sometimes quite gritty, quite grainy, quite grey in appearance, but that's normal for the material process used. So as long as we re-educate not just the technician, but also re-educate quality QA departments, the inspectors, to say that is not a bad joint, that is wetted correctly, but the appearance will differ based on your process, then that would bring down the need to rework. That's what's really important we have to get across to people. Do not rework things that do not need reworking. We're not going by the overall appearance, we're going by, when it comes to the solder joint, the wetting angles, the wetting characteristics, not a bright, shiny joint.
Right. People don't realize that whenever they rework something, they're introducing the potential for a reliability issue. It's like going for surgery. You might require surgery to save your life, but if you're going under the knife and going under general anesthesia, that in itself has a risk, right? And you have to balance the risk and the reward. So you I guess the same can be said. I've heard it said. I'm not sure if IPC says this. I want to think they do in some regard. That you never rework for cosmetic reasons. And I don't know if that's a standard or just a good practice or both. But never rework for cosmetic reasons. Deal with the, like you said, some things look prettier, some things look less pretty. But as long as they're functional, that's what matters.
Yeah, and that is the problem with hand soldering. Each joint will look different. Each assembly will look slightly different. If you're hand placing and hand soldering, one component may be perfectly aligned from lead to land. The next component may be slightly misaligned, skewed, but is still within the allowable limits. So we need to shy away from, is it cosmetically perfect? We need to consider what we call form, fit, and function. Are we within the acceptable range for that component? Because if we are, leave it. Because the more you rework things, the more you are going to increase man hours, material costs, but in turn, you could be affecting the reliability of the part. Every time you reapply the heat source, we're going to increase intermetallic growth within that connection that could make it less reliable. And that's the things people don't consider. They look at the science behind the process. They are concerned, does every assembly look identical?
Right.
And we're concerned, is it
even in robotic
reliable?
soldering, you're not going to get a perfect identical match every time, right? It's just going to be a little differences. When it comes to choosing the right equipment, we talked earlier about the different things one needs. Let's just concentrate on the soldering iron for a moment. I can buy a soldering iron for $20 or $30, and it just plugs into the wall. There's no on-off switch. We've seen those. We have some at our company, mostly to tin wires. But and I can buy a soldering station for a few $1,000s, and anywhere in between. What would be in your world? I'm not talking brands here. I'm just talking about what type of soldering iron do you begin recommending? What would be the bottom? What would be in terms of features? And where do those features stop being valuable and they're just a little bit more glamour? You know what I'm saying? Where do you consider the minimum acceptable technology type and and you don't really need to go past another point, whatever that point may be?
Well, straight away, I always say to people, you need to buy equipment designed for this industry. You need to make sure it is temperature controlled. You were saying about the type you can just plug in. There's no on and off. That tip will just get hotter and hotter and hotter. To the extent it may start to glow red, that tip is getting so hot. You put that onto a printed board, regardless of the board material, whether it's an FR4 glass fibre woven cloth board, it could be a paper impregnated board, you are going to cause thermal damage. So we want to make sure that it's temperature controlled, either with a dial or buttons on the unit, or there are some particular equipment, soldering iron types, where you can control it by the tip itself. So by changing the tip, it can change the temperature. That is vital, because you need to make sure we can set the temperature based on the materials, the fluxes, the solders. We need to make sure that we can change the temperature to suit the component type, the board type. That is the first thing. That is vital. We then want to make sure that we have the tip selection. So you want to make sure that we can buy in the correct units, where we can buy the different tips to match different component types and component sizes. But you can get some soldering irons where you can lock the temperature so the operator can't change it. That's not always necessary. Long as they know this is the temperature we need to use and do not alter it unless you seek prior approval first. They don't need the lockout feature on it. They don't need the type where it goes into sleep mode. That would be beneficial, because that way it's bringing down the tip to a safe temperature to prolong the life of the tip. That's not always necessary, but just the basics of tip availability and tip temperature.
What, other than holding the hot end of the iron, as we talked about earlier, what safety precautions for humans and for the board or component should individuals take when engaging in hand soldering and rework activities?
Personal protection. So simple things like safety glasses, people quite often overlook. If you're cutting leads to length, there may be debris that's going to be flying around. Making sure that we do have safety glasses available. We have to consider things like if parts are ESD sensitive, that we are grounded correctly. So whether it's the use of a wrist strap, so if you're going to be seated during your normal work operation, heel grounders aren't always suitable because you may lift your feet up. Whereas I'm sitting now, I've crossed my legs, so my feet aren't touching the ground. So we obviously make sure we have a wrist strap on. They know how to wear the wrist strap correctly. I still see people attach it over the cuff because it's more comfortable for them.
Sure.
Or it's loose and it moves around. It's like, well, we need that good connection. Make sure they're testing it regularly, whether it's once a day, twice a day, whatever's required for their company. That's very important. But for the safety of the assembly, the components, the boards, as I keep on going back to, is temperature control. That's the key thing with safety of the assembly, that we don't overheat it, that we don't cause thermal damage, lifting lands, burning the board, measling that I mentioned earlier, is all forms of thermal damage.
Yeah, excellent. How did the choice of soldering materials affect the soldering process? So if someone's using a high temperature solder, obviously you need a higher temperature, but are there other things besides the temperature setting on the iron that different soldering materials manifest when they're soldering? Are there different reflow characteristics? Do things flow differently? Is the soldering process affected by the flux selection and things like that?
Yeah, definitely. As you said, with higher melting point solders or higher reflow temperatures, yes, you will need high tip temperatures. But we normally find the higher the reflow temperature, the difference, the appearance of the final connection. It often isn't going to be that bright and shiny. it will look quite dull, gritty and grainy, as I mentioned earlier. Also, with like PB3, we may not get the same wetting angles. We may not get that very low concave fillet between the parts being joined. We may not get that nice feathered edge. It may look more, I wouldn't say convex in appearance, but it may just have that higher wetted angle. So the appearance to the human eye will look different. Also, with different alloys, you may have different plating types to the component lead, or different plating type to the board. For example, if you're using gold-plated parts, you may have to consider gold removal. The problem with when solder and the gold bond together, that area may become quite brittle, what they call solder embrittlement issues, due to the gold plating. So we have to consider, does it have to be removed first? We had to consider how it's removed. Some people may get a bit of emery cloth or a foil and try and mechanically remove it, which is obviously not the correct method for gold removal. We obviously have to heat the area, double tin the area. But then we have to consider process control. Has that process been done? Has it been done correctly? Because we can't visually inspect. Once that joint's been created, unless you've got X-ray vision, you can't see through to see if that gold's been removed and removed correctly. So there is quite a few issues we have to consider when it comes to soldering materials.
And you talk about inspection and what we can and cannot see. What role does inspection and testing play in hand soldering and rework processes? And what are some of the best practices for quality assurance, for QA? I've been to a number of production houses, assembly houses, and sometimes I see photographs. I think Bob Willis sells, or used to, maybe he still sells all the photographs of an acceptable solder joint versus a non-acceptable solder joint. How does the whole role of inspection blend in to the soldering process?
Well, the most important thing when it comes to inspection, make sure that the inspectors understand the process, the materials. They need to understand, going back to our previous question, when we were talking about high melting points, when we were talking about lead-free or PB3 solders, is the inspector aware of a change in the process? Are they aware of the change in materials? So they will understand why that joint or that assembly may look different to what they're more familiar with. They need to understand the end-use environment for that product. So what the IPC refer to as the different classifications of products. Because what may be acceptable for a Class 1 consumer product may not be acceptable for a Class 3 military or medical product. So they need to understand, especially if they are a contract manufacturer and the products do differ, they need to understand what we are building, what materials we're using. But also, it's not just the inspection of the completed assembly. It's also inspection of the process to make sure the process is set up correctly. And that's one step I always find people neglect to follow. They're just going to wait to the end of the process. It's all fully populated. We're about to bolt it all together. Let's look at the quality of the board. And the issue I find there is one or two boards may be perfect or one or two boards may be acceptable. But if you haven't controlled the process and the process starts to differ and go out of control, that's going to affect the quality of the end product. So we need to make sure that we also inspect not just the quality of the end product, but inspect the process itself to make sure that that stays consistent and in control. Because as long as your process doesn't change, the end product should generally come out to meet the acceptance requirement, whatever requirements you are following.
What's your take on robotic soldering? I've seen robot soldering out for a long time. I'm not sure if it's making progress or if it's the same, maybe slightly better controlled than it was before. But I can see certain advantages of it in terms of programmability, maybe repeatability,
Yes.
But it really doesn't have an intuition, even though it might have camera systems on it, or it does have camera systems on it. It's still not human. But I'm just wondering what your take on robotic soldering is, and particularly factoring in AI, artificial intelligence, and where do you think that's going?
I think any form of automated process, robotic soldering being a great example, is good in the correct area of the industry. If you are mass producing, the more we can produce, the quicker we can produce, generally the lower the cost. Doesn't have to be lower the quality, just lower the cost. But there are some aspects where we do need to make sure we do always maintain that higher quality, where automated processing may not be able to take over from manual processing, because the human eye can pick up on things more than, as you said, the robots themselves can't think for themselves. They can't look and say, that's not right. It may not recognize if it's going out of control. So we'd still need to have the human behind the machine. And the machine is only as good as the person that programmed it. So there is a benefit to it, but we still need the human there to make sure that everything stays consistent and in control.
Yeah. And it's hard to give a machine a certification. It's
very true.
it is hard to do that. Speaking of consistent quality, how can individuals stay updated on the latest trends and innovations and standards within the hand soldering and rework arena?
These podcasts are a great example. That's a good way of keeping up with the
good
industry,
answer.
changing trends. Yeah. The perfect. You paid me enough to give that answer.
Exactly. Yeah, checks in the mail.
Thank you. Just keeping up with social media is a really great example. When companies release new equipment or new technologies or release of new standards, new revisions, social media is a place to find out that new information. So you don't always have to go direct to a particular customer or a company because they release it to the world. But trade shows, I still fully support face-to-face interaction. Going to trade shows where they're doing demos of new equipment, giving it a go, trialing the new equipment, getting those suppliers to come into your facility to give demos, and you can trial the equipment. Many hand soldering equipment suppliers will loan you the kit to trial. So you're not just using it for an hour or so, you can use it for a week, a month on your production line, within your facility, on your real products, your real assemblies, to see how they work. I would always say speak to the suppliers, see what they can offer you. And they will come in and they will look at your process. If you say we have a problem trying to get the heat to transfer through due to ground planes, etc., they can say, well, we have this tip that does this, we have this equipment that does that. And they can tailor that to suit what you need. And you get that from the trade shows, you get that from social media.
Excellent. Does ART only do certifications, or do they also provide just general basic training? Say someone just wants to learn how to do something, but they don't care about the plaque on the wall. They just want to know how to build something right. Is that something that your company provides?
Very much so. And that's where we started off, as I said, 35 years ago, where we had companies that said, we need to know how to do this. We need to know how to hand solder this particular part. So we would put together those bespoke courses, that syllabus, to suit the needs of that company or to suit the needs of that assembly. And then over time, we've started to offer courses where they may not need to be certified. It may be they don't have any contractual requirement for official traceable certification. They just need the basic training of how to do something, whether it's basic training on how to inspect, and that could just purely be all theory-based. They need to know, as you said, about Bob Willis and his posters he used to produce that show what's good, what's bad. We would go through and say, this is good because, this is not good, or this is not acceptable because. Or we may have companies that say, we've got new starters that don't know what end of the iron gets hot. And we offer introduction to soldering, introduction to rework. we then can move on and do the enhanced soldering or enhanced rework classes for those that have the knowledge, but they want to expand on their skills. So we can offer those courses as well as obviously IPC certifications. We can do audit preparation for our customers. Consultancy. They may say, we have all the certifications in place, but we believe something's gone wrong in our process. So we can go in and work with them to set up their process, even down to, we need to buy new equipment. What do we need? And I can say, yeah, this is a great brand of iron. This is a great brand of soldering wire. But they need to know how to then use that within their process. So we could go in and work with them to help them buying the equipment, buying the materials, the fluxiers, the flux removers to suit their particular product or assembly.
You talked about certifications for soldering. I know there are certifications to become a trainer. You are a trainer, a master trainer. Are there certifications just for inspectors? Someone who doesn't actually do the work, but has to be qualified to inspect someone else's work?
Yes, there is. It does depend on the assembly itself. If it is a populated printed circuit assembly, then they can be trained to the IPC A610, which is the acceptability of the electronic assembly, where it is all theory-based, but it goes through acceptability and reject criteria for through-hole, surface mount. It talks about coatings, cleanliness, damage to balls, damage to the components. If they are dealing with cable and wire harnessing, then we have the IPC A620, acceptability of the cable and wire harness. So that's not just soldering, that also can cover crimping, IDC, installation displacement, coaxial cables, as well as wires and terminals. And that both those documents go through acceptability of the completed assembly.
Excellent. And we're about out of time, so let me just end with this. I teased my audience about maybe tales from the crypt, tales from your experience. Can you share something that you find memorable in maybe a customer anecdote? You don't need to tell us who the customer is. We can protect the guilty if that's the case. But some story that, where effective hand soldering or rework techniques played a crucial role in the success of the product, or maybe the funniest, fail that someone had that you guys had to kind of train their way out of?
The strangest one I come across, where they were told to buy in components from a recognised supplier, and they didn't like the cost of those components from a recognised supplier, so they bought them from elsewhere and didn't realise the components they bought in were a lot cheaper because they weren't actually active components. They bought in dummy training components.
Like top-line components.
When we took the
shells.
top off, there's no circuitry inside. It's just a plastic body with leads connected to nothing. And they had put them through an automated soldering process. They had 10,000 boards, and not one of them were functional because they thought it was a way of saving money.
That's funny. Well, they saved money. They accomplished one goal, right? Created a few other challenges. That's funny.
Oh, definitely.
I'd love to see the look on their face when they discovered that they did that. When you do training, do you use dummy components generally, or do you use actual live, real components that maybe are obsolete, or how do you get that inventory?
We use live active components for a number of reasons, because we will, after they've done any rework or even repair, we would like to check functionality. So we may get out the multimeter and buzz it out to make sure if they've done a track repair, that they've connected that track correctly. But also on some of our bespoke classes, it is a working circuit. There may just be some simple LEDs that at the end, when we apply a power supply, the LEDs will function and flash in a certain order. So of course they have to be functional components. And it makes it more fun. They get something to keep at the end.
Right.
And they know that what they've done is correct.
And particularly in the earlier part of their career, where they haven't had too much fun already, right? It's still mesmerizing, at least at the beginning.
Yeah.
I would think also that some dummy components, depending on their purpose, may not have the same thermal characteristics as an actual
Very
component.
true.
And I'm thinking like a dummy BGA or something, something kind of large that has some mass to it. That might reflow, although we're not generally hand soldering a BGA to a board, although you could be reballing, which is a hand soldering thing. But I would think that certain dummy parts would just have a different experience in soldering than the actual production part in terms of
very true.
heat required and things like that, right? So you don't want to train people on something that is less dense, that reflows faster, and then all of a sudden they go back to their company and things don't reflow the same way, right? So
and they get very confused in a board fun and go, why is this acting different to what I did on the training class last week?
Right. So if they didn't buy the lockable iron, they start turning the dial up, right? Thinking something's wrong with the iron.
So we do try and keep it as true to life as possible. When you come into our practical training room, we've got all the correct ESD flooring, all our benches are connected to ground. We make them put on their wrist strap. We talk about why we are testing the wrist strap. So when they sit down, even though it's in a training environment, they're sitting at a desk, a workbench that will be very, very similar to what they'll be using in production.
Right.
So they'll get into that habit. And that's what is important. They get into those safe habits than those bad ones that they've introduced to elsewhere.
And share with my audience where in the world your facility is located.
We are based in Essex, just outside of London, in the UK.
And do you have training facilities outside of that location? Do you do remote training?
We do remote training. We can actually box up all our what we call off-site training equipment. We can put it in the back of all our work vehicles and take them anywhere in the world where necessary. Often, if there's a large group of students need to be trained, it's more cost effective for one trainer to go to them than them all coming to us.
Sure.
So we can take all the digital inspection equipment, the cameras, the microscopes, soldering irons, portable fume extraction. We also have a sister site in Italy, which is ART Europe, leading edge training, that offers all the same classes that we offer here in the UK. Excellent.
Well, Debbie, you've filled up my available space for knowledge on hand soldering. I think I'm full. But thank you so much for sharing your wisdom and your experience in this often understood, often misunderstood art of hand soldering and desoldering and all the things that go along with that. I really appreciate your generosity of your time and your wisdom and your expertise and sharing with me and my audience.
Thank you. It's been a pleasure.
And would it be okay? My audience, they're quite inquisitive. They may have some questions. Is it okay if I share your contact information with them?
Please do. I'm happy to answer any questions they may have.
I've never had anyone say no, but I've often wondered as soon as we're done recording if they go, "Why did he ask me that?" I didn't want to say no. No, but most of actually that's not true. I did ask one person, but I edited it out if I could share their information, and they just looked at the camera and they went, "No."
Oh dear.
Okay.
I wasn't being polite.
Right.
In all honesty. If anyone has any questions, please ask.
It seemed very sincere. So I will, to my listening audience, when you get to your destination, if you're driving, don't look now, but when you get to your destination and it's safe, go to your podcast app, look at the show notes, and you'll see contact information for Debbie Wade and the company. And if you're watching this on our YouTube channel, at the Reliability Matters YouTube channel, just look down here somewhere. There's a Show More button. Press that, and you can also see within the show notes Debbie's contact information. So Debbie, once again, thank you so much for being my guest. I really appreciate it. It's been a delight and quite informative. So thank you.
Thank you.
Well, that's another episode. Thanks for listening to or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on your favorite podcast app. Or if you're watching this podcast on the Reliability Matters YouTube channel, be sure to click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks for your questions and episode suggestions. Please keep them coming. I love to hear from you. Send comments or episode suggestions or questions to mike@mikeconrad.com. That's Conrad spelled with a K. Once again, thanks for listening or watching. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.